What's going on, apes? Welcome to another lecture. We've already kind of talked about, we've seen the availability of water around the world and how that can be unpredictable. For example, years of low precipitation can cause insufficient water supplies for human needs. And, as a result, humans have learned to live with variations in water availability in several ways. So today what we're going to look at is how we channel the flow of flood waters with levees and dikes, how we block the flow of rivers with dams to store water, and even how we divert water from rivers and lakes to transport to distant locations. And we're even going to finish up here with how we can obtain fresh water by removing salt from the salt water. So we're going to look at each of these water distribution methods and examine their costs and their benefits. So let's get moving. First thing we'll look at is preventing what happens when we have too much of water, so preventing flooding. And if we want to hold back, we all know that rivers will overflow their banks from time to time. So there's natural levees that are created by the flow of the water, but then there's man-made levees, and we're going to see that these are used quite often. And all they are, again, is there a bank that's built up on each side of the river to prevent that from overflowing. The largest in the United States is the Mississippi, with, you can see, 1,500 miles of levees. And you can see here on the map on the right, I mean, essentially the entire river is levied off, again, preventing that from flooding over. And even, major cities like St. Louis, New Orleans are protected by these levees. But again, as we know, there are costs, there are benefits, and there are cons to all things in life. So the problem with our levees is we all know that it's important for a river to overflow its banks from time to time to that the sediments that the river is carrying will increase the fertility of that area, and levees inhibit this. So instead, that sediment's just going to flow into the ocean rather than those floodplains. And by preventing flooding in one location, it could cause an increase in flooding downstream. So again, if we look at this map real quick, you can maybe prevent it up here, just south of Little Rock, but then maybe further down near Jackson, you'll have flooding because that water was restricted and wasn't allowed to go out onto the floodplain. And it's inevitable, like we said. Rivers are going to flood, levee or no levee. So what this does is this encourages people to live in floodplains. And again, unfortunately, it does happen where there is a collapse or there's even enough rain for a spillover. Perfect example is after Hurricane Katrina. You can get an idea of the levee was going right up almost the middle of the picture here. You have a tremendous amount of rain from the hurricane, and you can see just the homes that were just inundated with these floodwaters. So levees do not guarantee water will be held back. Moving on to dikes. Dikes are holding back water. Now we're holding back ocean water. A perfect example, this is huge in Northern Europe, especially the Netherlands, where the land is below sea level. And then people in the Netherlands have been doing this for 2,000 years. And you can see that's why when you see like Amsterdam, they have all the windmills. The windmills used to work as pumps to get that water back out in the ocean. Today they use wind power as well, but also diesel and fossil fuels to power those pumps. So we know how we can hold water back, but we're also going to restrict the flow. And that's just by using a dam. So a dam's just going to be built. It's going to run across a stream or river, and it's going to hold that water back. And what we get as a result is a reservoir. And a reservoir is just this body of water that's created by the dam. So we have Lake Mead in Las Vegas. There's many different lakes all over the country, which we'll see that are the result of dams. And there's many uses. We can get it for, you can see the Lake Mead there. 90% of the people in Las Vegas rely on Lake Mead for their water use. Lake Mead is also used to power the city of Las Vegas for electricity. Flood control is very important, where they can open and close the dam depending on water flow and availability, and then even recreation, fishing, boating, all sorts of things can be used for that reservoir. So dams by the numbers. If we look at the Colorado on the right and how often it's dammed, you can see starting from the up in Wyoming, we have dams from where it starts all the way to where it empties in the Gulf of California. So as of 2013, there's 845,000 in the world, 84,000 in the U.S., with the Missouri being the largest reservoir system, storing 24 trillion gallons of water. And we can see here that Missouri River starting all the way up in the mountains in Montana. And as we go through, you see dams along the way, creating reservoirs, but also using for power plants as well. So how do we use dams in the U.S.? Only 3% are hydroelectric, 18% are used for flood, and a lot of them are used for recreation. It's important to point out, though, they're also used just to create scenic lakes for housing developments. Here's just north of Charlotte, North Carolina. It's called Lake Norman. It's a pretty decent sized lake, but again, you can see all those homes along the lake. Imagine, again, that water is being held back by a dam. Those homes wouldn't be nearly as expensive as they are if they were in their natural environment where it would just be rolling hills. So again, there's good things, there's bad things. Let's get into the pros first. We already know there's hydroelectric power. Yes, seasonal flooding can be prevented. That's a good thing. Again, like we said, people are starting to live in more flood-prone areas, but there are more costs. So lots and lots of money to build these dams. To give you an idea, when the Hoover Dam was built in 1936, it cost $49 million. That's about, in today's terms, that's about $640 million to build a dam. And people are displaced. Again, you're going to hold all that water back. Perfect example is the Three Gorges Dam in China. Just looking at it, it's almost a mile and a half across, and you can see that 1.2 million people had to leave the area. And again, to give you an idea of how much water was held back, it took 2 years for that lake, the reservoir, to finally fill up. So again, 140 towns, villages, all this water inundates and displaces a lot of people. And we have some environmental problems with dams. They do interrupt the natural flow of water. We saw that with the Colorado River, which is supposed to be emptying into the Pacific or the Gulf of California, which it doesn't now. But you have even organisms that rely on it, like salmon. Salmon have this innate, they know where they were born, and in order for them to reproduce, they have to swim back up from the ocean, upstream the river, and spawn where they were born. And that also indirectly affects bears, who rely on them as a food source. So what engineers have tried to do is create these fish ladders. And a fish ladder is, again, here we have our dam. The salmon wants to go up the river to where it was born. Obviously, the dam is in its way, so you kind of create these ladders, and the salmon go up the ladders and eventually make it. I mean, it's not 100% efficient, but it's better than nothing. Another problem is these power plants. These power plants have huge turbines, and as the water goes through the dam, those turbines spin, creating electricity. But again, a fish isn't going to do too well when these turbines are spinning at an incredible rate, and you see lots of fish dying every year. Seasonal flooding, we know, is a good thing because it provides the land with fertile soil, but there's also plants and animals that rely on a large flood every now and then, maybe as a source of water or to create a habitat and allow it to succeed. So what we're seeing now is there is a cost benefit to dams in a lot of places where dams were built, and they were really built in the 1930s, 1940s as part of civilian corps engineers. But what we're noticing now is a lot of dams aren't really necessary anymore. So you can see that there's now, since the mid-90s, that dams have been started to be removed. And in the past 100 years, over 1,000 dams are the result of this. Now they're bringing that back, this natural flow of water. And there's a cool video on the lecture showing you this time lapse of a dam removal up in the Pacific Northwest I suggest you check out. All right, so there's water in some locations, there's water unavailable in others. We've been doing this for thousands of years. You have a Roman aqueduct in the picture here. Romans have been doing this for over 2,000 years, and we still do it today. So an aqueduct is just a canal or ditch. It's just going to carry water from a lake or river to where people need it. And you've all been to LA, I'm sure, one of the largest cities in the United States, a huge demand for water. So they need to bring that water in through aqueducts. Unfortunately, what's going on though is um, the aqueducts being used today, as you can see in this picture in California, have been around for a long time and they're still in use. And 55% of the water in those aqueducts is either lost through evaporation or leakage. So here you have all this water coming to LA and 55% isn't even making it. So New York, LA are relying on these aqueducts, and unfortunately they're not very efficient. There is a benefit though. You have clean, beautiful water coming from pristine areas. Here we have the aqueduct going to LA. It's coming from the beautiful Sierra Nevada mountains, the snow melt. It's clean, it's fresh, and it's a guaranteed good water source. Unfortunately, there's a lot more costs than there are benefits. So again, just like as in dams, the construction is very costly. We'll see how it screws up habitats here in a second. So you have construction, again, very expensive. And here again, you see that this built in the early 1900s, similar to what it was then. And again, evaporation, leakage, things like that. It's not very efficient. It can disrupt land above ground. It breaks the land up into fragments, and even underground, it's going to disrupt the land during construction. What we do also is we divert rivers. Here you can see a small stream in California, but what instead of it following its natural course, here's our aqueduct sending the water down to LA instead of where it would have naturally flowed. And as I mentioned earlier in the lecture, here's the Colorado River today. So all rivers eventually empty out into the ocean, but unfortunately the Colorado River, because we are damming it so much, we're taking the water out for consumption. This is what it looks like today. It doesn't even end up into the ocean. And a great case study is the Aral Sea. And so in the 1950s, what happened is the Soviet Union diverted two rivers that fed the Aral Sea that we find in Central Asia. And here you can see from 1960 all the way to 2012, the amount of water lost from that sea. And what happened is the decrease in water coming from those two rivers increased the salinity of the lake. And not only did it increase the salinity, but here's where the dam was, it broke up the lake into the North and South Aral Sea. And as a result, it destroyed the local fishing population, resulting in less fishermen, less employment, less money coming in. It reduced the area by 60%. And this was huge because lakes kind of have their own weather systems. So instead of a lake being there to provide cooler summers and actually warmer winters, now the opposite is happening. What we're seeing is increased dust storms that affect local climates now. So now summers are hotter, winters are colder. And as of today, they've done a cost analysis and they've determined that the South Aral Sea is way too expensive to be saved. So unfortunately, it's just going to continue to dry up, and all efforts are now towards this North Aral Sea. So again, this would happen in the 1950s. You can see in the span of 80 years how damming two rivers can have horrible effects on the environment and the people living around that area. We're going to finish it off here is how, we already know we have a certain amount of water in certain areas of the world. We are running out, and hopefully technology can save us. So desalination is happening now. Most of it is happening in the Middle East, where you can see 54% of all desalination is occurring. But the good thing is technology is advancing, and because some of the cons of this is it is quite expensive. So there's two types of desalination, where you're just taking salt from out of the water and producing fresh, clean water. And the first one is distillation. What you're doing here is you're boiling the water, creating steam. That steam is captured on this coil. The steam condenses onto the coil, and as a result, it drops out as fresh water. But again, you're going to get this brine, all the leftover very salty water. The problem with this is it takes a ton of energy. It takes a lot of energy. So it's monetarily and it's even environmentally expensive. But like I said, technology is making some advances. There are talks now, and again, if you're following this online, if you click on this, there's a cool link to showing you how They're maybe tapping geothermal energy, getting energy from inside the earth to power these desalination plants, distillation, to make it more cost effective. Our second one, and I'm sure you've heard it before, is reverse osmosis. All that's happening here is we're taking this salty water. There's this permeable, semi-permeable membrane where the water can go through, but the salt cannot. Much more efficient, not as costly, but there is that, again, that brine that remains. So there are some issues because you cannot put that brine, that water, that super salty water on the land. It destroys the soil. You can't put it in shallow coastal regions because it harms fish and other aquatic life forms. So what they're kind of doing now is they're taking this brine to the deep ocean, emptying it into the deep ocean, but that high salt content still does cause harm to local ecosystems. So there's our water. We're going to finish it off with looking at water availability. And just to give you an idea, 5% of the Earth's population lives in Eastern Africa, where only 1% of Earth's fresh water is. So hopefully through technology, through desalination, through sustainability, we can be able to keep these standards of living we have today and even improve some people's standards of living. And to give you an idea, the UN estimates that 1.2 billion people on Earth live in regions with scarce water. So something we're going to have to deal with, hopefully with technology and education, and again, sustainability, we can make it happen.